In this lesson, we're going to talk about how to use the elimination method when the coefficients are different. By the end, you should be able to use multiplication and elimination to solve a system of equations. The elimination method is when both of the equations are in standard form, so x's and y's are on the same side, and you're adding or subtracting the equations in order to eliminate one of the variables. If the coefficients are different, what you're going to want to do first is find the least common multiple for the coefficients. And then you're going to want to multiply one or both of the equations in order to get opposite coefficients there. You must multiply to everything, so if you choose to multiply one of the equations, make sure that you multiply to everything. The steps for elimination are going to be to multiply to get a common coefficient. We need the coefficients to be the opposite, so same number but different signs in front. Then you're going to add or subtract depending on what's there, and to eliminate one of the variables. You'll solve, and then you're going to plug in the solution to that part into one of the original equations to solve for the other variable. So number one, we have x minus y equals 4, and we have negative 5x plus 3y equals 6. So here we have different coefficients for x, and we have different coefficients for y. Now on problems like this, where the coefficients in front of x and y and one of the equations is both 1, then it doesn't really matter which one you choose. So I'm gonna eliminate the x's. So in order to eliminate the x's, I'm going to have to get a common coefficient here. So I would need, in order to cancel out with negative 5, I would need there to be a positive 5 in front of this x. So I'm going to multiply everything by positive 5. Now remember that I have to multiply this entire top equation. So this is going to change to 5x minus 5y is equal to 20. The bottom I didn't change, so the bottom is still going to be negative 5x plus 3y equals 6. I'm going to combine the two equations through addition and subtraction. So I know that negative 5x and positive 5x, they cancel. Negative 5y plus 3y is negative 2y, and 20 plus 6 is 26. I can solve this. I divide everything by negative 2. And I know that y is equal to negative 13. For the x's, in order to figure out what the x is, I'm going to take negative 13. I'm going to plug it back into one of the two original equations. So I'm just going to pick the first one since that one's a little bit easier. Instead of x minus y, I'm going to have x minus negative 13, which would change to x plus 13. So x plus 13 equals 4. If I subtract 13 on both sides, what I will have is x equals to negative 9. And so my solution here is negative 9 and negative 13. And then as usual, to check, you could plug in negative 9 and negative 13 into both equations to make sure that the statements are true. Here we have 3x plus 4y is equal to negative 2, and we have 2x minus y is equal to 6. Again, in order to eliminate, we have to have a common coefficient. The coefficients for x are different. The coefficients for y are different. Since this y on the bottom has a coefficient of 1, that's going to be the one that I want to work with. In order to cancel out with positive 4y, I would need a negative 4y here. In order to get a negative 4y, I would need to multiply the entire equation by positive 4. So I'm not changing the top equation, so I'm just going to carry that part over. So 3x plus 4y equals negative 2. When I do the bottom equation, that's going to give me 8x minus 4y is equal to 24. Again, don't forget to multiply the 4 to everything in that bottom equation. And then I'm going to eliminate. So combining, I know that positive 4y minus 4y, those are going to end up canceling. Positive 3x plus 8x is going to give me 11x. And negative 2 plus 24 gives me positive 22. I divide everything by negative 11, or by 11, not negative 11. The 11s go away. 22 divided by 11 is 2. So I know that x is equal to 2. I'm going to take x and I'm going to plug it into one of the two original equations. So I'm going to choose to plug it into the bottom one because the bottom one seems a little bit easier. So instead of 2x, I'll have 2 times 2 minus y is equal to 6. That's 4 minus y is equal to 6. Subtract 4. Negative y equals 2. So that means that y is equal to negative 2. So my solution for this one was 2 and negative 2. As usual, if you plug it back into both of the original equations, you should be able to check to see if your solution was correct. If we look at this next one, we have 6x plus 7y is equal to 6. 4x plus 7y is equal to 6. We have 6x plus 5y is equal to 20. Again, coefficients are different here. Since all the coefficients are different and neither one of them are 1, it's going to kind of go back to just pick the one that you want that is easiest for you to see. So I'm going to pick the x's just because I'm dealing with semi-smaller numbers here. In order to eliminate the x's, I'm going to need to figure out a common multiple, the least common multiple for 4 and 6. So I know that the multiples of the least common multiple of 4 and 6 would be 12. And so I'm going to make sure that one of them is negative 12 and one of them becomes positive 12. So for the top, in order to get 12, I would have to multiply everything by 3. And for the bottom, in order to get 12, I would have to multiply everything by 2. Now, one of them I want to make negative, so I'm just going to make the top one negative. So to multiply the top by negative 3. Again, that way I have a positive 12 and a negative 12 so that they cancel out. 4 times negative 3 is negative 12. X minus 21y equals negative 18. Remember to multiply it by everything. The bottom is going to be positive 12x plus 10y is equal to 40. Again, multiply everything. When I combine, the x's will cancel out because negative 12 and positive 12 will cancel out. Negative 21y plus 10y is negative 11y. And negative 18 and positive 40 is going to give me positive 22. Divide everything by negative 11. And I get y is equal to negative 2. In order to get the next one, I'm going to pick one of the two equations. I'm going to plug in negative 2. So I'll pick the bottom one. 6x plus 5 times negative 2 equals 20. 6x minus 10 equals 20. 6x equals 30 when I add 10 on both sides. X is equal to 5 when I divide both sides by 6. So my solution here would be 5, negative 2. Again, to check it, you would plug it in to both equations to see if it's true in both. Our word problem here at Starbucks, 3 coffees and 2 muffins costs a total of $7. So I can write my first equation is 3x plus 2y is equal to 7. X being the cost of muffins, or cost of coffees. Y being the cost of muffins. And we know that 2 coffees plus 4 muffins is equal to 8. So again, on this one, I'm going to pick one of the variables to cancel out, either the x's or the y's. I'm going to choose the y's because all I would have to do on the top is multiply it by -2 in order for it to cancel out with the 4y on the bottom, because I would need a -4y on the top. So when I do that, I'm going to have -6x minus 4y is equal to -14. Remember, I didn't change anything on the bottom one, so that's 2x plus 4y is equal to 8. Combine, so -6 and 2x gives me -4x. The y's cancel out, and I get -14, and 8 is -6. And I divide that, I get x is equal to 6/4 or 3/2, which would be $1.50. So I know that muffins, or the cost of each coffee, is $1.50. I would use that in one of the two other equations. So if I plugged it into this one, this would be 2 times 150 plus 4y equals 8. 2 times 150, that's $3, plus 4y equals 8. 4y equals 5. If I subtract 3 on both sides, y would be equal to 5/4, or 1 1/4, or 1.25. So I know that a muffin costs $1.25. Again, finding the solution in the context of the problem, you would want to be able to explain that coffee costs $1.50 and muffins cost $1.25. Before watching the next video, please consider the following. To solve a systems by elimination, what do you do?